Welcome back to College Algebra. In this lecture video, let's take a look at finding the vertex of quadratic functions. So quadratic function actually come with two different forms. One of them is your ax squared plus bx plus c form. The other one is called the general form, which is a times parenthesis x minus h whole thing squared plus k. So I'm going to try to talk about its characteristic down here, and at the same time I'm going to graph this particular x squared, and start labeling all the things I'm written up here. All right, so let me move this down a little bit. I need a little bit of space to draw that graph. All right, so quadratic function has two forms. All right, the graph of a quadratic function is called the parabola. So for x squared, I'm going to go ahead and graph this in the graphing calculator real quick so I can start labeling. All right, it's a parabola. It's a U shape like we mentioned before. The very bottom or the very top, the very bottom or the very top of our parabola is called the vertex, because this particular function is open upward. So if I have a parabola that opens downward, then the very top, will also be called the vertex. So if I open up, the very bottom is your vertex. All right, which we denote as h and k. All right, the x value is h, the y value is k. So for this vertex right here, for my x squared function, my vertex right now is located at 0, 0. All right, in an application problem, the very bottom, the very bottom is called the absolute minimum. That is the lowest point. It's the lowest point of your parabola. So that means the y value is the smallest y value, of all y value that's on the parabola. So if the parabola opens downward, then the very top or the vertex is called the absolute maximum. So we use the word absolute maximum, absolute minimum when we're dealing with application problems. Parabola is actually symmetrical. Half a parabola is mirror image with the other one. It's symmetrical. So that means I can actually cut my parabola in exactly two halves. Then the left side and the right side will be symmetrical. All right. So when I cut exactly in half, that this line got to go through the vertex. So this line right here is actually called the axis of symmetry. So the same thing right here. Maybe make a different color for that one. So this line I'm using to cut my parabola in two halves is called the axis of symmetry. To the right and to the left, of my axis of symmetry, the parabola are mirror image. So this line I'm drawing is a vertical line. So, the axis of symmetry will always be written as x equal to a number. It's going to be written as an equation of a vertical line. All right. So very bottom, very top is called the vertex, or very bottom can also be called the absolute minimum. Very top is also called the absolute maximum. We denote the vertex as using letters h and k. And the parabola itself, the quadratic function produces what we so-called the parabola. All right, let's look at this letter A. Where is this letter A located? This letter A is located in front of your x squared term. So what it's saying is if that A is bigger than 0 means positive. So if it's bigger than 0 or positive, if my leading coefficient is positive, my parabola open upward. If the leading coefficient is negative, less than 0 means negative, that means my parabola will open downward. Okay, so that's how we know just by looking at this 1x squared, that leading coefficient is a positive, I know my parabola will open up. So for any parabola open downward, that will be negative x squared. Okay, so if I will come over here and simply just insert a negative sign in front of my x squared, then this parabola will actually open downward. Okay, just like that. All right, let me go back and delete that. If the leading coefficient is between 0 and 1, number that are between 0 and 1 are considered as a proper fractions. Okay, so if I have proper fraction, that means my parabola will open wide. All right, why opens wide? So let me give you a quick example. Okay, so earlier I just had a x squared, right? So if I put a proper fraction, like a 1/3, in front of my x squared, why does it open wide? Open wide actually simply means it actually opens upward a little bit slower. That's why it seems like it's wide, because your y value is actually very slowly. Your y value is actually has to times by 1/3. So whatever x you pick, that number will be squared, but then got times by 1/3, and that's the reason why the graph is actually not going upward very, very fast. So I'm going to put 1/3 in the parenthesis times x to the second power. So then it will open wider than the regular x squared. Okay, so let me put back the x squared as y2. So the x squared would just be inside of it. Okay, it opens wide because at 1/3, because when I'm finding the y value, okay, to get to that y value, all the number I pick for x will squared it. Eventually, will have to times by 1/3, which makes the y value smaller. Okay, if this leading coefficient is greater than 1 means anything bigger than 1, it will actually open narrow. Open narrow means it actually the y value actually shoots up very fast. That's why it appeared to be narrow. So let me delete the 1/3. I'm just going to type in 3x squared. Okay, so the first one is the 3x squared. It opens narrower than the regular x squared. So it's inside of it because the y value is actually what? It's actually, to get to the y value, everything got times by 3. Okay, so normally if I pick x equal to 1, my y value will also be 1 for the regular one. But because my first graph, the one that opens narrow, there's a 3 in front of that x squared, then whenever I pick 1 squared is 1, then times by 3, that will be 3. But when x is equal to 2, 2 squared is 4, then that 4 times by another 3 as a leading coefficient, it made the y value jump so much. Therefore, it actually opens narrow. It appeared to be opens narrow. Open narrow means the y value actually shoots upward faster. Okay, that's what that means. So there are two things that we're looking at on the leading coefficient. Number one, what's the sign of the leading coefficient? Positive means open up. Negative means open down. Then we look at the numerical value itself. If the numerical value of the leading coefficient is a proper fraction, it opens wide. If the numerical value of the leading coefficient is anything greater than 1, then you will open narrow. All right, so let's give this a try. Okay, I just want to kind of summarize what I just did. So find the vertex. So this quadratic function is written in the general form, which is, let me write it down here. As a matter of fact, let me write below it real quick. Let me rewrite it. Let me say the general form is a times x minus h whole thing squared plus k, and my function is negative parenthesis x plus 3 squared plus 4. Okay, so what is the vertex? Well, Let's see if we can match it up, okay? If I match everything up from the formula to my function, a is going to be -1. X to x, this formula right here is a subtraction sign, but this is actually a plus sign here. Okay, so that doesn't match. For them to match, for the subtraction sign to match in my problem, it has to be x minus -3 whole thing squared plus 4. Okay, right? Because -1 times -3 is why it becomes +3 here. So if the formula is calling for a subtraction sign in front of the h, when I have a plus sign, that plus sign simply implies it's actually subtract a negative. All right, plus sign to plus sign, k to k. So what is my vertex? My vertex, it turns out my h is actually going to be -3. It's not +3, it's actually -3 because the formula calls for negative sign here. All right, my k is exactly the same, going to be 4. All right, so let me write it down. My a was -1. So what is my axis of symmetry? Axis of symmetry is the vertical line that cut through my parabola, cut my parabola in 2 halves through the vertex. So we have to write the axis of symmetry as x equal to number because that's a vertical line. And what would that number equal to? It got to equal to the x value of the vertex. All right, open up or down, that based on the leading coefficient. That's looking at the signs. If the sign is negative, it opens down. All right. Open wide, open narrow, that based on the numerical value of your leading coefficient. So since this is not a proper fraction or bigger than 1, so if it's exactly 1, it actually opens what? It's actually neither. It's just open normally. Okay, kind of like that. I'm going to say neither. All right, so just by looking at the function, I get an idea what my parabola will look like. So this parabola, I know it was open normal, but it's open downward with the vertex located at -3, 4. All right. Now, what happened if the quadratic formula is written in the ax squared plus bx plus c form? If for us to find its vertex, okay, we will use our vertex formula. So the h can be found by plugging into this formula called -b/2a. So maybe you may have remembered something called completing the squares when you learn about solving quadratic equation. So the -b/2a is derived from completing the squares. So to find the vertex, I need to know my coefficients of my quadratic function. So let's give it a try, okay? So for my quadratic function written in the ax squared plus bx plus c form, I just use this formula, the vertex formula to find the vertex. So my a is 8, my b is 10. I don't need my c right now because the formula doesn't call for it. So my h, which is the x value of my vertex, is going to be -b/2a, which is going to be -10 over 2 times my a, which is 8, which is -10 over 16, -10 over 16. Reduce. It's going to be -5/8. All right, that's -5/8. That's my h. That's my x value of the vertex. So to find the k, all I'm going to do is substitute the x value back into my function. Remember, when we input the x value, we always output the y value. So if the -5/8 is the x value of the vertex, then I would need to input the x value of the vertex into the function for me to output the y value of the vertex. So all we're going to do is just plug it back in here. So I'm going to say to find the k, I'm going to say this is going to be f of -5/8, which we can do this in the calculator real quick. This is going to be 8 times -5/8 squared plus 10 times 5/8 minus 3. So I'm going to key this into the graphing calculator. That will give me the answer. Now, so after I found my h to be negative 5 over 8, I already know that I'm having decimals, okay, as a vertex. So I'm not even going to attempt to trying to graph this, trying to find my vertex from the graphing perspective. I'm just gonna put this into the calculator, and it will tell me the y value. So 8 times negative 5 over 8 whole thing squared plus 10 times 5 over negative 5 over 8. Excuse me. Oh, Lord. That was right. Insert 8 times. And minus 3. All right, convert to fractions. All right, negative 49 over 8. Okay, 8 times negative 5 over 8 whole thing squared plus 10 times negative 5 over 8 and minus 3. All right, negative 49 over 8. So this is a negative. All right, so my vertex, negative 5, 8, comma, negative 49 over 8. All right, so my axis of symmetry got to be x equal, that vertical line cut through my parabola in 2 halves, got to be x equal to negative 5, 8, right? Because because axis symmetry passes through the vertex. Is the only point it touched the graph is the vertex, so my equation got to be the x value of the vertex. All right, let's look at my leading coefficient. My leading coefficient is positive 8. So if it's positive, it means I will open up. All right, numerical value is a, which is greater than 1, so you will open narrow. All right, so just quickly in this video, talk about how we can find vertex of a quadratic function and talk about its characteristic. All right, that will conclude this video. Thank you for watching.